This is question number 6. So we have f, which is an x squared, and we have g, which is x, and it's only from 0 to infinity. And obviously we have this parabola, and we have this x. We're only looking from 0 to infinity. And I'm asked to draw it. So my graph's going to be and that's going to be f of x, and this one's going to be g of x, and that's going to be at 1, 1, that's going to be at 0, 0, and that will get full marks. So definitely we will represent, so the integral from 0 to 1 of top curve is g of x minus f of x dx, or you could write from 0 to 1, top curve is x minus x squared dx. To state the bound region, so if I come to here, interactive math to from 0 to 1 of x minus x squared dx, and that gives me a bound area of 1/6 units squared. Okay, part D then moves to, now consider the region bound by f of x, g of x, and the vertical line x equals b. And I know that the area trapped is 1/3. So this here is 1/6. Then I need to get 1/3, 1/6 plus 1/6. So I need to find an area, the area up here, where that value of b combined gives me 1/3, so therefore that's got to be a 1/6 as well. So if I did the integral from 1 to b, my top curve is now x squared minus x dx, set it equal to 1/6 and solve for b. So if I now make that positive and that negative, and I go from 1 to b, and my answer has to equal 1/6. I'm going to solve for b. And it's either 0 or it's 3 on 2. And of course 0 will give me 1/3 because that's 1/3, 1/6 down here. So b equals 3 on 2 is going to be my value. State the region bound by this area here, by these lines. So I've got, you replace x with x on 2, it's a dilation by 2 from the y. The same here, and I've doubled my b to be 2b. So now I have going out to 2b, therefore the area should be doubled. So it should, area should equal not 1/3 but 2/3. And if I now have 4b and 4 f of x, 4g of x, and the line of x equals b, I'm actually stretching it up this way. So it's going to be an area of 4/3 units squared. So we have this dilation happening. Dilation by a factor of 2, the area will double. Dilation by a factor of 4, the area will quadruple. Now consider these functions. I've now got the square root of x and the line of x, which is the inverse of this. In fact, I've now just got the square root of x and x. So this area and this area should be the same because it's just the inverse. So what have I got? I've got a horizontal line of y equals d. And it's telling me that the area between here and here is equal to 1/3. Well, if the area up here is equal to 1/3, and all I've got is a swapping over, then this is going to equal b, or equal 3 on 2. So state the value of d. So d equals b, or it's the value d equals 3 on 2, because I just got an inverse of the previous situation question.